All right, so we have done graphing of some basic rational functions. We're going to get into graphing some more complicated ones, some higher degree ones, higher level functions. But in order to get into graphing these higher order functions, we need to talk about some asymptotes. Now, vertical asymptotes aren't going to change. Vertical asymptotes are going to happen anytime you need to throw a value out of the denominator, a value out of the domain, because it creates a zero in the denominator. All right, so that's not going to change. However, in some cases, you're going to have a horizontal asymptote. In some cases, you're going to have what's called an other asymptote. They can be oblique asymptotes, which are slant asymptotes. You can have parabolic asymptotes. You can actually get into even higher degree asymptotes than that. And here's your rules. The way that you're going to know the horizontal versus other asymptote is based solely on the degree of the numerator and the denominator. All right. Let me add the r to the end of the denominator there. All right. So we're going to go through a few examples. I'm just going to make these up as I go and just give you an idea of how to look at it. All right. So you have three possibilities. You have the possibility that the degree of the numerator is less than the degree of the denominator. So an example for that one, let's say we had x plus 3 over x squared minus 9. And that's an example for clearly the numerator has a degree of 1, denominator has a degree 2. For that example, because the denominator has a higher degree, you're going to automatically tell me that y is equal to 0 is your horizontal asymptote. All right, you can also have a situation where the degree of the numerator is equal to the degree of the denominator. We've seen that with a few of the problems we did. So the example for this one would be, let's say we had 3x squared minus 9 over 2x squared plus 6. All right. So we have x squared in the numerator, x squared in the denominator, and what we're going to do is divide the coefficients of the x squareds, or whatever the highest degree is. So in this case, we've got 3 over 2, so we would have a horizontal asymptote of y is equal to 3 over 2. So that's nice. Those are the ones we've seen so far. The new one is what happens if the numerator has a greater degree than the denominator. So the way you might see this, right, these are just examples I'm making up so you can kind of see what we're talking about, is if we had, let's say, x cubed minus 8 over x squared minus 4. Okay? So this numerator has a larger degree than the denominator, so what you need to do is figure out your OA. All right, now I'm going to say OA because it's, in this case, it's an oblique asymptote because this degree is 1 higher. There's a one degree difference between these two, but it applies for any oblique asymptote or any other asymptote. You are going to do some form of division. All right, so I'm going to write divide to find the asymptote. Okay. Now, the reason I'm saying divide is you might do synthetic division. You might need to do long division. It really just depends. So for this example, we'd have to do some long division because we are clearly not dividing by a linear term. So I'm not going to actually ask you to do that particular problem, but that's the idea of what you would need to do. Okay, so for the rest of this video, I'm going to do the next 4 examples here, just showing you whether you have an oblique asymptote or an other asymptote or a horizontal asymptote. Okay, so if we take a look at problem number 1 here, I want to look at my highest power in the numerator, my highest power in the denominator. All right, so in this case, my highest power is in the denominator. So as soon as I see that, I know I have a horizontal asymptote of y is equal to 0. There is no oblique asymptote. So actually, I'm going to write down none. All right, this is an either-or situation. You either get a horizontal asymptote or you get an oblique asymptote. You don't get both. Okay. All right, problem number 2. Let's take a look at our leading terms here. We have a third degree polynomial on top. We have a third degree polynomial on the bottom, which means they match. If they match, I can immediately say that I don't have an other asymptote, okay, whether it's oblique or parabolic. There's no other asymptote. I do have a horizontal asymptote, and I'm going to divide those leading terms. So y is equal to 4/3, okay? So let's see about the last 2 here. All right, problem number 3. We have a second degree polynomial in the numerator and a first degree polynomial in the denominator. This is not a horizontal asymptote. All right, so none. I have an other asymptote. Because it's a degree difference of 1, we're going to say it's an oblique. All right, that's not going to be something that you're going to need to know about, but just wording-wise so you understand what I'm talking about. To find the oblique asymptote, I am going to do synthetic division. So we have a denominator here of x minus 1. So I am going to use positive 1 as what I'm using for synthetic. And then I just want the coefficients of the numerator. So x squared is 1, x is negative 6, and my constant is 4. All right, give myself a little working room here. We're going to bring this first number straight down. So there's 1, multiply, add up again, multiply, add. Okay, so I'm going to go ahead and mark these pieces. So the negative 1 is my remainder, the negative 5 is my constant, and the 1 is my x to the first term. Now here's the fun part about other asymptotes, whether they're oblique, parabolic, or any of them. Your remainder doesn't matter. All right, it absolutely does not matter in the slightest. What matters is the rest of the problem, the constants and the coefficients of x. So for this problem, the way you're going to tell me the oblique asymptote, all right, or the other asymptote in a different situation, you're going to write y is equal to, because this is an equation of a line, x minus 5. So this was the coefficient, so 1x to the first. I'm lazy and I just wrote down x. And then minus 5 was our constant. This remainder has no meaning when it comes to the actual asymptote in terms of graphing it. Okay? So that's problem number 3. Let's take a look at number 4 here. Number 4, we have 2x to the 4th over an x squared. So higher degree is in the numerator, which means that we do not have a horizontal asymptote. We're going to have an other asymptote. Now, this one's going to be kind of a pain, at least in my opinion, because I can't do synthetic. So I'm going to set myself up for a little long division here. X squared minus x plus 1, and I'm dividing into, so 2x to the 4th. I don't have an x cubed term, so I need a placeholder there, minus 4x squared, whoops, let's do this, minus 5x plus 2. All right, do a quick check. So this is 4, 3, 2, 1, none. And now I'm going to start my actual process of dividing. I'm going to take this leading term, and I am going to divide it by that leading term. So 2x to the 4th divided by x squared is 2x squared. Distribute. So that's going to become 2x to the 4th minus 2x cubed plus 2x squared. Line everything up. And now you need to subtract this whole mess. All right, so make sure you're doing each part at a time. So those will cancel out. All right, so let's see what we got here. 0 minus a negative 2 would be positive 2x cubed. Negative 4 minus positive 2x is going to be negative 6x squared. I'm going to bring down the other pieces and start it again. So I'm going to take this x squared in front, and I'm going to divide it into 2x cubed. All right, so 2x cubed divided by x squared is going to be positive 2x. Distribute. So 2x times x squared is going to be 2x cubed minus 2x squared plus 2x. Line it up and subtract it. Okay, so 2x cubed minus 2x cubed, they gone. Negative 6x squared minus negative 2x squared. Be careful with the double negative. You could distribute if you wanted to. That's going to become negative 4x squared. Negative 5x minus 2x is negative 7x. Bring down the little plus 2 here. And we're going to do it one more time for our division. So I'm going to take this leading term, negative 4x squared, divided by x squared. So negative 4x squared divided by x squared is going to be negative 4. Now I need to distribute. So negative 4 times that is going to be negative 4x squared, positive 4x, and negative 4. Now I'm going to take this whole mess and I am going to subtract it. So negative 4x squared minus negative 4x squared, they're going to cancel. Negative 7x minus 4x is going to be negative 11x. And then 2 minus negative 4 is going to be positive 6. So I can't do any more division because I've run out of polynomial. And if I try and take negative 11x and I divide by x squared, it's going to become fractional. So that's not the issue. So this end piece down here, this is your remainder. But since the remainder doesn't matter for our oblique or other asymptotes, we're not going to use it. What we're going to say here is that the oblique asymptote, I'm sorry, I keep saying oblique, it's the other asymptote, is y is equal to 2x squared plus 2x minus 4, which is this answer from the top part here. Okay? I'm going to go ahead and cut this video here because I want you to have a chance to ask any questions about the horizontal versus other asymptotes. And then the next video, I'll do the actual graphing that comes with some of these problems to figure out, do you have oblique, horizontal, other asymptotes, what's going on there? All right, any questions, send me a message, and I'll be glad to help you out.